All right, let's dive in. Today, we are taking a deep dive into a really powerful open source component for the Convex platform. It's called the WorkPool, and it's designed to solve a nasty latency problem that can bring even the most amazing apps to a grinding halt.
Okay, so imagine this scenario, right? Your app is really starting to take off, users are flocking to it, but then a user does something that needs a fast response, and they're just stuck. They're waiting. And why? Because they're stuck in line behind 100 background jobs that aren't even urgent. This is a huge, huge latency problem. So what's really going on here? Well, it all comes down to what we can call the one queue problem. In a lot of systems, especially when you're just getting started, every single asynchronous task, they all get thrown into one giant, messy queue.
It's kind of like that massive security line at the airport, you know? It doesn't matter if your flight is boarding right now or if it's 5 hours away. Everybody gets in the same line. The super urgent stuff gets stuck behind the stuff that could totally wait.
And this right here is the perfect example. On one side, you've got a user who's literally waiting for an AI chat response to pop up on their screen. On the other side, you've got 100 webhooks that need to be processed in the background. One is absolutely critical for the user's experience right now. The other can happen whenever. In a single queue, the unimportant task just completely clogs up the works for the critical one. So how do we fix this whole mess? Well, that's where the Convex WorkPool comes in. It's a component designed specifically to solve this exact challenge. So what is the WorkPool exactly? You can think of it like a super smart scheduler that you can just add right into your project. And the coolest part, it's not some secret internal platform magic. It's an open source component built completely on top of the standard tools Convex already gives you, like tables and the basic scheduler. So here's the core idea, and it's really powerful. First, you create different pools or queues for different kinds of jobs. Maybe one for those fast AI responses and another for the slow background webhooks. Then, and this is key, you set limits on how many jobs from each pool can run at the same time. This protects your critical user-facing tasks from ever being starved for resources. All right, so let's get into the nitty-gritty. How does this thing actually pull this off without some special hidden API? The answer is, honestly, it's really clever. See, instead of just chucking every single task onto Convex's global scheduler, the WorkPool steps in and acts like a traffic cop. It actually stores all the work that needs to be done in its own set of database tables. Then it carefully feeds jobs to the real scheduler, making sure everything runs smoothly. And the way it's architected is just so smart. Check this out. There's a main work table, and that holds all the heavy data for a task. That stuff only gets written once. But then you have these smaller, lightweight tables like pending_start that act as the actual queues. They just move around tiny references instead of rewriting huge documents. It's just way, way more efficient. Okay, now we get to the really juicy stuff. Because building a robust queuing system on top of a transactional database, well, it comes with some hidden traps. The creator actually calls them minefields. And Ian McCartney, the guy who built this component, he just nails it with this quote. He calls them minefields because they're these sneaky little problems that you just don't see coming when you're developing. Nope. They wait to pop up on a Friday night when your app is getting tons of traffic and suddenly slows to a crawl for no reason you can see. So let's talk about minefield number 1, phantom reads. Here's what happens. The main loop goes to the database and says, hey, give me the next 10 jobs to do. Simple enough, right? But with Convex, you have these super strong serializable transactions. So if someone adds a new job to that list while you're in the middle of reading it, bam, transaction conflict. The whole thing fails and has to retry. You can get stuck in this horrible loop just retrying over and over, making zero progress. So what's the big brain move here? How does the WorkPool get around this? Well, instead of asking for tasks up to right now, which is always changing, the loop does something really smart. It picks a moment in time, a specific timestamp, and says, give me all the jobs scheduled before this moment. Any new jobs that come in, they get a leader timestamp, so they're completely outside the range the loop is looking at. No conflict. It's genius. All right, on to minefield number 2, and this one's called tombstones. This is a classic database problem. See, in a lot of systems, when you delete a row, it doesn't just poof, disappear. It gets marked as deleted. It leaves behind this little ghost, a tombstone, that gets cleaned up later. And in a busy queue that's doing tons of jobs, you can end up with thousands of these things super fast. And the fix for this is, again, so smart. A naive query would have to scan past all those thousands of tombstones just to find the next real job. It's crazy slow. But the workpool, it remembers the very last item it processed. So for the next batch, it tells the database, hey, start looking for jobs after this specific point. It just completely leapfrogs over that whole graveyard of old deleted jobs. It's so much more efficient.
And like Ian says, you wouldn't just stumble upon this solution on your own. This is deep, low-level stuff, which is exactly why having it all wrapped up in a battle-tested component like this is so, so valuable.
So when you step back and look at all this, you realize it's not just a collection of clever tricks. It actually tells you something really important about the whole philosophy behind how the Convex platform is built. You know, a lot of platforms out there follow a batteries-included model. They give you every feature you could want, all built in, but they're kind of a black box. You're locked in. Convex takes a different path. It gives you these incredibly powerful but simple building blocks, the primitives. And then it encourages the community to build amazing open source components, just like the workpool, right on top of them. It's about building with composable pieces, not just using a pre-built product. And this thing isn't standing still either. The vision for the future is even bigger. We're talking about things like keyed queues, which would prevent one noisy user from slowing everyone else down, or built-in prioritization, so you can give your pro users better performance than your free users. It's just going to keep getting better. At the end of the day, the workpool is this perfect showcase of that whole philosophy. You take simple, solid building blocks, you layer them intelligently, and you end up creating something incredibly powerful. And that really leaves you with a big question, doesn't it? What other amazing systems are just waiting out there for us to build, just by putting these simple pieces together in new and clever ways?